it. You should be comfortable with any one procedure. If you're comfortable with the Minitab, all done. Or if you're comfortable with the Excel, that is also okay. Or if you are someone who want to follow the very old method of doing everything manually, and if you're good at it, then also it is okay, right? But everything will have some plus and minus. So Minitab is easiest. So probably next week when you listen to us, particularly I will be staying throughout the sessions next week, and everything no, you will be able to feel comfortable, and not only me but also even the other trainers when they are teaching you the same thing for the third time, then you will be able to digest it very well, and then you will feel the transformation, right? So don't miss on the upcoming sessions. Okay, so now I want to utilize this time to educate all of you on hypothesis testing. What do you know about hypothesis testing? Can you please speak out for a few minutes? What is hypothesis testing? Hypothesis
So
testing
comparing
means,
before
very good.
before and after.
Comparing the before after scenario.
Yes.
Is there an improvement or not? Is there an impact or not? People are claiming an improvement is achieved. People are claiming there is an impact. People are claiming there is a difference. But still, a doubt exists. You understand? If somebody is claiming, if somebody is making a statement saying that, no, sir, the impact is coming from this. If the impact is coming from this means that this is nothing but the root cause. Yes or no? Is one of the root cause. If an impact is coming from something, then what is that? That is one of the root cause, right? So in hypothesis testing is a validation procedure. Hypothesis testing is a claim validation procedure. Claim can be a statement about a comparison. Claim can be about the root cause. Claim can be about the performance of two groups. Claim can be comparing sample and a population. Remember all of you, long back, Maggie was banned. Am I right? Maggie was
Yes, sir.
banned for a particular deviation,
Having lead content in their product.
higher lead content. So how they found it? They picked up a sample from the market and tested the sample and found that they tested around, let's say they tested around 10 packets, and all 10 packets lead content is higher. If continuously 10 samples lead content is higher, that is an indication of your entire population having a lead content higher. Yes or no? How come 10 samples continuously, two randomly picked up from different sources, all of them have a higher lead content? If all of them have higher lead content, there is something wrong at the process level. If a mistake is happening rarely, that is okay, understandable. If mistake is happening repeatedly, now the understanding is different. There is a problem with the process, yes or no? This studying a sample and judging the population is a kind of hypothesis testing known as one sample test. Do you understand? Studying a sample and then judging the population. Please note, judging the population means we are judging the characteristics of the population. Yes or no? Sample also has lead content. Population will also have lead content. But by knowing the lead content of the sample, we are actually judging the lead content in the population. Several hundred tons of Maggie packets were destroyed by studying a few samples collected from the market. Yes or no? The whole decision-making process behind banning Maggie was one sample t-test. One sample t-test. Whatever you calculate using your sample data, they are known as sample statistics. Whatever you calculate. You calculate average, you calculate standard deviation, or you calculate anything that is possible. All of them are known as sample statistics or simply statistics. Why do you calculate sample statistics? Because you want to judge, you want to estimate the population characteristics. The population characteristics are known as parameters. The population characteristics are known as parameters, nothing but the real characteristics of the population. Do you understand? The real characteristics of the population should be called as parameters. We are always interested in knowing the real characteristics, yes or no? But problem is we can't do 100% inspection. Yes or no? Particularly in the food industry, if you test all Maggie packet, then what can you sell it? You can't, isn't it? So many scenario, 100% inspection is not possible. In all those cases, we only study the sample and then judge the population parameters. So with the known characteristics of the sample, the unknown characteristics of the population can be estimated. This process of uh, making decision about the population or making decision about the unknown characteristics is known as hypothesis testing. Clear? So hypothesis testing, in simple terms, is a decision-making procedure. Clear, all of you? It's a decision-making procedure. And we always make decision only if the data is also supporting the information provided by the experts. We should make decision only if the data also confirms the information provided by the experts. Let us, can one of you tell me an example opinion or example information given by an expert? Just make a statement. Normally experts, let us, particularly in the context of analysis space, you are curious of knowing the root cause and one expert is coming and telling, hey, this is the root cause. Can you make such a statement? Maybe out of your any problem solving exercise. Temperature is the reason for poor efficiency of the boiler. Operating temperature of the boiler is the reason for the poor efficiency of the boiler. From whom this opinion is coming? From an expert, from a thermal engineering specialist. He is saying your boiler is operating in a wrong range and that is why you are experiencing poor efficiency. Now, what is his statement? His statement is actually pointing to a root cause. Any statement that is pointing to a root cause is known as alternate hypothesis. Saying that a factor is critical, saying that a factor is root cause, saying that there is an impact. These are all alternate hypotheses. But always in hypothesis testing, you must start by framing the null hypothesis, which is the opposite of alternate. Don't start with alternate. You start with null. Can one of you convert this particular statement into null? The statement is operating range of the temperature, current operating range of the temperature is the root cause for poor efficiency of the boiler. Now, can somebody tell me the opposite of it? You can use the same language used by me and then make the opposite statement. Current operating temperature is the root cause for the poor efficiency of the boiler.
So
now, what will be the opposite
operating
statement?
Current operating temperature is not the root cause.
Very good.
For the
That means Satish has framed a null hypothesis now. You must start with the null hypothesis. I can always use different other languages also, giving the same meaning. The current operating range is not critical to efficiency of the boiler. That means entire range is acceptable. I can operate the boiler at low temperature, medium temperature, high temperature. The efficiency, there is not going to be much change. If there is not much change, the factor is not root cause. All of you are with me? If you are getting disconnected, then you will feel definite. No, you will remain isolated, right? So please participate. Okay.
Yes.
So always start with null hypothesis. A statement of no impact is null hypothesis. The current status is null hypothesis. What is current status quo? The company is running the boiler in a particular temperature range. They believe that they are correct. And saying that it is correct is null hypothesis. If you say that the current practice is wrong, then it is alternate. You understand? So describing the current practice in the form of a statement is null hypothesis. The opposite is alternate hypothesis. Alternate hypothesis is also known as research hypothesis. Let me come to the point. Let us talk in terms of the analysis space. Temperature, operating temperature is not critical to efficiency. Let me go to Minitab. I opened a Minitab now. We are right now in a topic known as hypothesis testing. We should first start with null hypothesis. The current, whatever can be the factor, current operating temperature is not critical to efficiency. This is null. And operating temperature is not a root cause. This is also same. Or operating temperature has no effect on efficiency. All are giving same meaning. Am I right?
Yes.
Yeah. Efficiency at low temperature is equal to efficiency at high temperature. Both that is also same meaning, yes or no? But here it is mathematical statement. Minitab will talk in terms of mathematics only. Whenever you are able to bring in an equality symbol, please note you are making a null hypothesis. Clear? Whenever you are bringing an equality symbol, your statement is null statement or your hypothesis is null hypothesis. So once all of you, will you be able to frame the null hypothesis correctly hereafter? Imagine you have you have three machines. Your doubt is the problem is coming from the machine. The rejections are because of the type of the machine. Now, what is the null hypothesis?
Machine is not defective.
Machine is not.
Not defective. They are working.
There are three machines you have, machine number 1, machine number 2, machine number 3. All of them are doing the same operation. Lot of rejections are coming. Now the doubt is the one of the machine is troubling. Now the doubt is one of the machine is troubling. Maybe machine number 2 or machine number 3 or machine number 1. And now you have to frame a null hypothesis. Machine is the root cause of the rejection. What is the statement? Alternate.
Alternative.
Alternate. Yeah.
And there are three machines available. So machine is the factor we are studying. Can you see, all of you? The factor we are actually investigating is machine. And the factor exists in 3 levels. What are the 3 levels? Machine number 1, machine number 2, machine number 3. Now, out of the 3 levels, which level is good for you and which level is bad for you? You need to understand. And whichever is good, will make it part of our process. Whichever is bad, we'll try to eliminate from our process. This is called solution. But before offering a solution, we must be clear about the root cause. So whatever your inner feeling or the expert opinion is giving you, you should be able to confirm it with the help of data. Whatever experts are telling, data should also confirm the same. Then only you can move forward. If expert is telling something and data is not supporting it, you must understand experts can also be wrong. Right? It is better you turn yourself into an expert. After listening to all the experts, you must turn yourself into an expert and then take a right decision. Okay. So now this is understood. Null hypothesis, alternate hypothesis. So in my case of machine example, machine type or machine is not critical to the rejection. Do you understand? This is the null. Null means the symbol must be H0. Alternate means H1 or HA. Machine is or machine type is critical to rejection. Do you understand? Also, please note, validation, see, in hypothesis testing, the decision is arrived on null hypothesis only. The decision is arrived on null hypothesis only. What is the decision? We either reject the null or we fail to reject the null. Do you understand? These are the only decision. Look here, we are not at all using the word alternate. Can you see here? Please note, if it happens to reject the null, it means current practice is wrong. Yes or no?
Yes.
If we are rejecting the null, it means current practice is wrong. It simply means it can actually lead to a conclusion that the factor under suspect is critical. And please note, whenever you reject a null, then only a decision is arrived. Yes or no? If the moment you make your company understand that the current practice is wrong, then only they will come forward to effect the change. Yes or no? If you can't prove that they are currently wrong, how can they accept your suggestion? Nobody will accept, isn't it? See, please note, whether you effect a good change or not, you should never effect a wrong change. Yes or no? So whenever you are rejecting null, you have to be very, very careful. Right? Be careful, extremely careful while rejecting the null. Because otherwise it is not good for your career. In spite of all your efforts, you will attract a bad name. What is the point of making a wrong change? Whether you make the good change or not, don't make a wrong change. Whether you help people learn or not, don't confuse them. Yes or no? So this is the normal practice. Like 100 culprits, 100 criminals can escape, but one innocent should not be punished. Same logic here, right? So whether you are able to reject the null or not, but if you are rejecting the null, it should be correct, right? If you are not able to reject the null, don't worry. Let the problem continue for some more time, right? But intentionally or unintentionally, you should never try to effect a wrong change. Imagine a scenario where company's practice is correct and you have still, effected some change. Look at the scenario. While trying to solve a problem, you brought a brand new problem into your company. That should not happen. Yes or no? So while rejecting, be careful while rejecting a null. See here, rejecting a null hypothesis wrongly is known as type 1 error here. Do you understand? I'll further iterate it. Rejecting a null hypothesis wrongly. It is nothing but rejecting a true null hypothesis. Is known as type 1 error. Am I right, all of you? Type 1 error will happen only when you are rejecting the null. If you are not rejecting it, don't worry, nothing is going to happen. But if you reject it, there is a chance of rejecting a true null hypothesis. You must know it. Why this risk is coming? Why this risk is also this risk is also known as alpha risk. You know why this? Why I'm cautioning you on this? You are only relying on a sample data. Yes or no? You are not studying everything 100%. You are only taking 5 sample, 10 sample. So your skill on sample size, choosing the right sample size. Your skill on right sampling technique. Your skill on sample collection frequency. Your skill on sample collection period matters a lot now. If you don't know how to decide all of these things, your data might give a misleading conclusion. And then you will end up making a type 1 error. If you very frequently make a type 1 error, your company will not come to you next time. They may even decide to kick you out. So that's why I caution all of you to be extremely careful about type 1 error. But we should also admit that the only way we can eliminate the type 1 error completely is 100% inspection, which is also not possible. So, certain amount of type 1 error is generally tolerable. You should know that. That is known as alpha risk. The permissible alpha risk is 5%. The permissible alpha risk is 5%. And we call it as, in hypothesis testing, we call it as level of significance. We call it as level of significance, which is 5%, which is 0.05. Clear, all of you? Declaring level of significance is the first step. Any game should start with declaring the rule to be followed. Yes or no? Otherwise, the game cannot be interesting. So it's a decision-making game. And general practice is 5% risk is allowed unless otherwise specified. But pharma industry, healthcare industry might demand for 1%. Some other areas that that has some application related to safety, some critical parts, there also they can demand 1%, even 0.1%. You need, but the general practice is 5%. Some companies can relax it up to 10%. So you need to understand the context and first decide. But the rule once decided should be followed throughout the game. In between, you are not supposed to change. All right. So first step is understood.
Excuse me, sir.
Second step. Yeah.
Excuse me, sir. Sir, I have a
Yes. Who
small
is that?
question
You
that
please be louder. Your
can
voice is very, very feeble to me.
sir, can you hear me? This is Shibralina.
Yeah.
Okay. Sir, I just have a small question. When you say that the level of significance vary, if it is a pharma sector or healthcare sector, it should be 1%. So, does it indirectly means that the level of significance vary with the size of the company?
No, not size of the company. Based on the application. Based on the application. See, this is normally decided by the company only, but not based on the size of the company. Company can be small, company can be big. But the application of the particular, product If it is something related to health concern, we can't admit that much risk. RK also can add. Yeah.
Please note, I invent a medicine. I invented a life-saving medicine. That medicine, I tell that suppose you give that medicine to 100 people, 5 people will fail, 5 people will die. The other one is, I give a confidence that if I give to 100 patients this medicine, chances are only one fail, one may die. 99% success will be there. Which you would prefer for medicine? For medical field, which one will you prefer? 5% or 1%?
1%.
That's all, simple, right? In my case, I have a nut. My motor car, there is a bolt and nut there. I find a bolt and nut from the shop, if I buy 100 times, only 5 times that nut and bolt will not fit in. Or I pay double the price. And in 100 vehicles, if I put, only in one vehicle, it may not fit in. 99% success. I would prefer which one based on my cost? 5%. Yes or no?
5%.
I would not like to pay extra and then save that for 4%. Right? Okay. Thank you.
Yeah. So general practice is 5%, but for your case, you need to understand your industry practice and accordingly proceed. So second step, you need to frame the null and alternate. I taught you how to frame the null and alternate. Right? And step number 3. Refer to data if it exists. Or perform experiments to generate data. Do you understand? If data already exists, use it. Otherwise, you should generate. Now, one important condition to be understood is you must conduct the experiment in the as it is condition of the process. Do you understand? You must perform the experiment by running the process in the as it is condition. Clear, all of you understand this? Come on, yes, say yes, sir. You understand, right?
Yes, sir.
Now,
Yes, sir. Yes, sir.
during the experiment, you must purposely, change your X factor from the lowermost value to the uppermost value. Right? And record the changes happening in Y. Do you understand the statement? While performing the experiment, you must purposely change your X factor lowermost to uppermost. What is lowermost to uppermost? The current operating range. Because our doubt is whether current operating range is okay or not. Whether something wrong happening within the operating range. That is our intention. So, you change the X purposely from the lowermost to uppermost. For every value of X, you should note down the value of Y so that you will be able to understand the changes happening in the Y because of the changes you have made in the X. Do you understand? Very good. After that, step 4. Calculate the statistics to understand the parameters. Calculate the statistics to understand the parameters. What is parameter? The real characteristics of your process. Parameter means the real characteristics. The real way my process is performing, I am trying to understand, but I only have the ability to study the sample. Clear, all of you? I am interested in knowing the real nature of my process, but I only have the ability to study a smaller set of samples. So studying a sample and understanding a bigger population or understanding the nature of the process is a case of inferential statistics. This field of study is known as inferential statistics. So all hypothesis testings are inferential statistics, right? Okay. So now please note, whenever you go for inferential statistics, there is a risk involved. Why there is a risk involved? Can you tell me, one of you, why there is a risk involved? You are studying only a sample.
And based on
Sample,
that,
if you take fewer sample or if you select sample from a wrong location, now
Wrong
your
sampling
decision can go wrong. This is known as sampling risk. One important sampling risk you all must control is type 1 error. Yes or no? If I want to understand how effectively the training program is going on, I randomly ask some questions. I may end up picking up a wrong example or wrong participant. Yes or no? There can be a participant, who will be attending 3 different training programs simultaneously. We have seen such participants, right? And suppose the timing of my quiz may not be appropriate. I ask questions right after the lunch. They're in a very sleeping mode, right? Because after lunch, it's difficult for anybody to listen to the lectures. So these are all the challenges while taking a sample. You have to meticulously plan your sampling plan. Even then, you can only minimize. You can't eliminate everything because not everything is under your control. So there is a risk involved. You should be able to estimate the risk. The tool that can help you to estimate the risk is, what is the name of the tool? P-value, right? And which actually stands for probability of significance. All right. So what is the tool that can help us to estimate the type 1 error we may commit while tending to reject a null hypothesis? While trying to reject a null hypothesis, what is the risk we may commit? Type 1 error. And p-value is a tool that will give a direct estimate of type 1 error. And what is the first rule, first step? Level of significance 5%. That means how much type 1 error you are actually permissible according to the current practice, industry practice, 5%. Now, please note, p-value is a function of variation and central tendency in your data. All of you agree with me? Do you understand what is central tendency and variation? If you collected, let us say 20 sample, will you be able to calculate an average? That is central tendency. And now with the 20 sample, you can also calculate standard deviation. That is variation. With the help of the variation, with the help of the central tendency, p-value is calculated. Don't worry about the manual method of calculation. Initially, we'll teach you a little later, but you can calculate p-value. If p-value is less than 5%, that is 0.05. What does it mean? The risk of type 1 error is below 5%. Yes or no? Now you are getting a confidence that the type 1 error is reduced to below 5%. If whenever you see p-value going below 5%, that's the time you can reject null hypothesis. Reject null hypothesis. Otherwise, you should not reject null. Clear, all of you? So, step 4, we calculate statistics, right? Step 4, calculate statistics to understand the parameters. And after calculating step 4, the step 5 is decision making using p-value. Decision making using p-value. And the method is, if p-value is less than 5%, reject the null. But the opposite, the other thing is also possible. If p-value is more than 5%, then fail to reject null. All of you understand? There are only two decisions. Please note, I am not actually commenting about alternate, because I leave the option to the concerned person to decide about alternate. He can further investigate if he has got the strength, or he can straight away conclude about alternate by seeing the decision made on the null. If null is rejected, then the likely chance is alternate is accepted.
Alternate.
If you still don't want to accept, it is up to you. Yes or no? So the decision is made. Please note, if it happens to reject the null, now the conclusion, the factor under the study is critical. Nothing but the root cause. Root cause is validated. Clear, all of you? How many steps in hypothesis testing we have seen?
5.
Now let me give a very another maybe a simple example, and then we will also perform hypothesis testing using
Just one question, that if probability of significance is less than 5%, uh, uh, then reject the null. Where is there is
Correct.
a acceptance criteria was the 5%. So I am just doubting why less than 5% is going to reject.
That's
my
not see, that is like not acceptance criteria. That is known as permissible risk. This much risk is permissible. See, what is your purpose of hypothesis testing? You are checking the current practice. Whether the current practice or whether the conditions in the current process are acceptable or not. We start with assuming that everything is correct. But we actually wanted to prove that a particular thing is wrong. That is why we started performing the experiment. So in order to say the current practice is wrong, when you are actually declaring something as wrong, first of all, your conclusion should not be wrong. Right? You are trying to declare something as wrong, current practice as wrong. But you very well know you do have a limitation. Why you do have a limitation? Because you did only a sample study. So the limitation within your study is what we call it as alpha risk. Right? And we also call it as type 1 error. So the type 1 error, the chance for type 1 error should be below 5%. If it is below 5%, yes, you can boldly declare that the current practice is wrong. See, when I say type 1 error is below 5%, it simply means if the same experiment is repeated 100 more times, at least 95 times, people within your company will get the same conclusion, will get the same findings. Now you are safe. Now you are safe. See, now there absolutely it is not compulsory that your company can believe all the findings. They may ask somebody to redo the experiment. If somebody redo the experiment and they come out with a different conclusion, then you have to cut a sorry figure. So we are just checking with our own. See why? Because sampling comes with risk. Imagine I conduct an exam. We assume that everybody put honest effort, study intensively, and then pass the exam. But there is also a chance somebody can do a hinky-panky in the final exam and still get a pass mark. Yes or no? So even though we design everything meticulously, still there is a random chance for the data to get generated. We might, by looking at the data, we tend to believe that the person has done a hard work, but actually may not. Certain amount of risk is involved whenever you study, whenever you proceed, decide using sample. So that we are checking. So if that is p-value is less than 5%, you can reject the null, which means you can declare your findings. If you are not even able to reject the null, don't declare any findings. Don't dictate any suggestion. Clear, all of you? That's all. If you know this, any situation can be handled. Okay, any questions before I take you through some example cases?
Sir, here, sir. Conceptually, this is clear, sir. Just for my understanding, like if p-value is less than 5%, we are using the term reject null hypothesis. And if p-value is greater than 5%, is fail to reject null hypothesis. I mean, just for the common terminology is concerned, instead of fail to reject null hypothesis, can we also use this accept null hypothesis also, can, sir?
A good doubt. So fail to reject null and accept null. See, my doubt can still continue. What is my doubt? Current practice is wrong. Yes or no? My doubt is current practice is wrong. I can say, I can always say, I do not have evidence right now to say that you are wrong. I performed an experiment, but my doubt can still continue. I can do the experiment again tomorrow and come back, and again tomorrow I will say you are wrong. But today I am not able to say. So the best answer is fail to reject null.
Sir, can I come?
But in certain scenario, failing to reject null can mean to accepting the null also, but not always. So
But
that
generally
is
use
why
this fail to
that's why
reject.
the best thing is fail to reject null. Sometimes accepting the null may also hold good, but sometimes only, not always. So why should we, take that risk of, which is helping only in some time? What can work well always is fail to reject null. If you use these languages, people will start seeing you as statistician. And then they will ask minimum questions to you. Right? So you can actually have a better control over the audience. Yeah. Yes.
Can I come?
Yes, sir,
Can I come,
please.
sir?
Yeah, please, sir.
Yeah, I hope you are saying only for me, right? Thank you very much. In fact, it is a very good question. I normally don't say that good question and all, but this is a good question. I have to say that. There are two things. One is we have to be humble, yes or no? Am I right? I'll come to this point later. We have to be humble, number one. Number two, I have not finished number one, but I'll come to the point two. Suppose you are making a case, you are going to a court against RK. What is this thing? RK is a bad guy. RK has stolen something. RK has stolen something. Yes or no? You are going to the court. Now, what is the judgment they will give? Will they give that RK is a good guy? He will not steal like that. Will he say like that? He is not bothered about that. He is not bothered about RK is good guy or bad guy. Yes or no? His job is only to find out whether RK has stolen or not stolen. Right? If RK is not stolen, will he say that RK is not stolen, therefore RK is a good guy? Will he say that? RK may still be a bad guy, but in this case, he has not stolen. He did not have the opportunity to steal. Otherwise, he would have stolen. Yes or no? That is why things will go. The story will go like that, not the other way. Here also, you are doing like this. Now, what is null hypothesis? It's a generally accepted statement. That is what is null hypothesis. Yes or no? Am I right?
Yes, sir.
Yes.
If you do not know, then take it for granted. It is a generally accepted statement, is a null hypothesis. show some reactions, yeah. Yes, sir, understood.
Yes, sir.
Right.
Yes,
Yes, sir.
sir.
Yes, sir. Yes, sir.
Very good. That is a generally accepted statement. Who are we to judge? Who are we to judge? It is going on, it is accepted, right? Now the question is, I fail to reject means what is accepted, let it be accepted. That's all. You still don't want to say that RK is good or bad guy. Right? RK is accepted as good or accepted bad, let it continue. Now the question is whether I have to reject it or not. Right? If I reject it, that doesn't still say that RK is bad. Right? There is a possibility that RK is bad. If I reject the null, right? RK is not good, but doesn't mean that RK is bad. Right? We have not noticed anything RK has done bad.
In
Right.
that incident, he is bad.
May, may I add?
See, he's taking personal issues, yeah. That is no incident, I am bad, man. I went off for 5 minutes. My wife called me, so I went. Right? Thank you. But yes, Gurpreet. Yeah.
Just in a simple language, we can say now, cause we have done this probability of significance value just to target that we want to reject the null, but we have failed to reject.
Yes,
That's
yes,
why we are using the term failed to
very good.
reject.
Why?
Yeah.
Why we want to reject the null? Because somebody who has the right has claimed. Now Tom, Dick, and Harry can claim, right? Want to reject. Only Gurupreet Singh has done a survey and then found out that it is not as accepted by others. Right? Then we say that, yeah, what he has found is true. We have to do further research. And this is the stepping point for doing PhD. Hypothesis testing is the stepping stone for doing whether there is a case for doing a PhD or not. That's all. Right? Thank you.
Shivakumar sir, just I have one more query, sir. I'm not from the manufacturing background, but from the example you mentioned, there are 3 machines we have with the machine case, sir, actually, which that is very clearly explained. But just for to understand, for example, we explained with the 3 machines actually, right? Machine 1, 2, and 3, and we wanted to understand which machine is the root cause for the failure, right? So, if I want to conclude like machine could be the reason, right? So then I will go with the one hypothesis testing actually, right? Suppose out of 1, 2, 3, if I have a doubt, like for example, machine number 2 is probably the most influential, factor actually. So in that circumstance, can I go directly with the level 2, like hypothesis that machine 2 could be the failure, or should I go in the 3-step
If
sequence?
you want to straight away investigate machine 2, then the reference value should be known to you. If there is a reference standard available, you can compare machine 2 against the reference. Whether this machine 2 is capable of meeting the standard or not. That way it is possible. But if standard is not available, you are just trying to understand whether any one of the machine is performing differently from the other. If you can always to have different purpose. If you are comparing the 3 machines against each other, that means one may be extremely better, one may be extremely bad. You are interested in knowing it. Then you need to study all the 3 machines simultaneously. Studying 3 groups simultaneously is known as ANOVA. Provided your output variable is measurable. Output variable should be measurable. Let us say surface finish produced by the machine. There are 3 machines and one particular machine is giving a better surface finish than the other 2. Or one particular machine is giving a poor surface finish than the other 2. And you study about all 3 machines simultaneously, then it is ANOVA. Because output variable is surface finish, which is measurable. The factor appears in 3 levels. More than 2 or more level, if it exists, the study should be known as ANOVA. If there are only 2 levels, you can use it by another method also, which is known as 2-sample t-test. If there is only 1 level exists, The study is known as one sample t-test. Like one machine was against a standard. So one sample t-test, two sample t-test, and finally ANOVA. ANOVA
Correct.
for n number of machines simultaneously. Even if you have 100 machines, you can still do it ANOVA. That is the advantage with ANOVA.
Correct, sir. But in case
Sorry,
of,
sir.
we are particular about any one thing, but for that case, we should have a standard difference. In that case, we can proceed.
Yeah, then only it is possible. No?
Clear.
Because we always
Clear.
want to make a comparison and then decide. For comparison
Clear.
purpose, either a standard must be available or one must be compared against other.
Correct, sir. Clear. Clear. Thanks. Thanks.
Sir, can I come, sir? Can I come?
Yeah. Yeah, please.
I hope I'm not confusing you, but I will tell you that it's going to be definitely confusing others, but to you should not confuse you.
Then
Why
better you
I'm
can
saying
confuse,
is,
sir, then
you have
better you can
said that
confuse them
going
next
to the
week.
level 2. No. Going to the level 2. Going to the level 2 is not an order, it's a good method. It is not a method. What we are teaching you is the structured way of approaching a problem and solving a problem. Yes or no? And in hypothesis testing, we never start with all are good or all are bad. No, it is not so. All are equal or at least one of them is different. That is a null hypothesis, right? And alternate hypothesis. All are equal is a null hypothesis statement. Keep it in mind. We never think about one is good or one is bad and all. All are equal. All may be equally bad or all may be equally good. I do not know, but all are equal. That is. Alternate hypothesis, all are not equal. At least one of them is different. Now you can find out that one is poorly performing or betterly performing. Understood? So your level 2 comes only after level 1. At level
Correct.
1, this is what is called, we have to approach only in a particular method. Like we never go and get married just like a girl, right? We go in an order, yes or no? My father goes, my mother goes, and my brother goes, and then he gets away, right? No, all these problems are there. Therefore, similarly here, an orderly way so that your married life will go smooth. There also, the selection will be very good only if you go in an orderly way. Go by problem selection, measurement selection, and then analysis. In the analysis, hypothesis testing, find the root cause. This is the cause. Then act upon that cause. Make it big or low, and whatever you want to do it, discard it or add more, right? Like that. This is how you have to go and approach. What we are teaching in this course is the approach and not the selection and the final decision, right? And nobody can teach you also that. Thank you.
All right. Now
I
let
hope I
us
am
take
not
one.
confused you, right? Though I started, I'm clear, I suppose.
Yeah. Let us take one example now, right? See here, in hypothesis testing, we are studying about a factor. Factor can be a machine, factor can be one of your vendor, factor can be your supplier, factor can be, the temperature, factor can be the trainer, factor can be, the chemical composition, anything. Sir, no? We are studying about the factor. And whether effect is coming or not, in order to know that, we measure Y. And your Y may be a continuous variable, may be a discrete variable. Do you know what is continuous variable and discrete variable?
Yes.
Continuous variable means it is measurable. Under such situation, you need to perform a test known as test of averages. That is what I am going to teach you today. Suppose if your Y is discrete means countable. Discrete means countable. That means only percentage is possible, no unit of measurement. Right? For continuous data, unit of measurement exists. But for discrete data, only using percentage you can express. For example, pass percentage, fail percentage, percentage rejection. These are all discrete. And for continuous data only, calculating average will be more meaningful. Calculating average will be more meaningful. But for discrete data, calculating proportion is more meaningful. So we divide the testing into two types of tests. One is test of averages, the other one is test of proportion. And within test of averages, we have four types of test. First one is one sample t-test. In this case, we compare a sample against population for which a reference value or a standard available. Do you understand, all of you? Whenever we compare a sample against a population reference, that is one sample t-test. And another one is two sample t-test. Now here we compare sample A against sample B. Do you understand, all of you? And there is one other test, ANOVA. Here we compare two or more samples simultaneously. Simultaneously means you can finish it quickly. Imagine you want to compare 10 groups, 10 machines. So much time it will take for you know to check the machines one by one. Yes or no? If you check the machine one by one, 10 times you have to perform the hypothesis test, which is time consuming. Rather, all 10 machines simultaneously we can check. That is advantageous. One is less time consuming and error also will be limited to 5%. If you do it everything separately, every time there will be a 5% error, then the total error can be much more higher than 5%. So ANOVA is better. And while performing the test, no company will share the historical information about the population. All of you agree with me? Or historical data. Historical data of population. Rarely companies will share you the history of the population. If you are an outsider, definitely they won't give. Imagine you are going for an audit to one of your supplier. Do you think your supplier will give all information to you? No. You have to decide only based on your sample. Whenever history of the population is not shared, you need to perform only t-test. But if the company comes forward and share the history of population means parameters will be shared with you. What are parameters? The population average and the population standard deviation. Particularly when the population standard deviation is revealed, only that time you can perform one sample G test. Clear, all of you? How many hypothesis tests I introduced? One sample G, one sample T, two sample T, ANOVA. What is the common thing across all the four? Your Y variable must be continuous. Correct? Y variable must be continuous. X, if the X factor exists in one level, then it is one sample t-test. If the X factor exists in two level, then it is two sample t-test. If the X factor exists in multiple levels, ANOVA. ANOVA stands for analysis of variance. Within one sample test, if the population parameters are revealed, you can go for one sample G test. Your predictions can be much more better now if the history is known. Clear, all of you? Now let us do this, with an example. Now imagine you are a dietitian. You are a dietitian. Now you want to recommend a cooking oil to your clients. You want to recommend a cooking oil brand to your clients. And your requirement is the fat content in the cooking oil must be less than or equal to 15%. Then you want to recommend this brand to all your clients, thousands of clients. And luckily you come across an advertisement where a company is also claiming fat content is 15%. Now you can do two things. One is you can blindly recommend it because you have seen it in the advertisement. Another thing is you can test and then recommend it. Which is correct? Shall I blindly do it or shall I check and correct?
Check and correct.
Check and recommend. So in order to check it, now I need to rely on the sample only. Because company cannot give me all the data or everything. If I ask, they won't give. So I only have to, whatever sample I can manage. If you are a dietitian, how many sample you will afford to buy? Some 10 sample, 13 sample. So limitation is known. Now, according to your capacity, you can buy the sample. Right? And since fat content is measurable, it is very clear Y is continuous. I can understand the fat content by sending the sample to the laboratory. Now let me say I decide to buy 13 samples for some reason, 13 or 10. Now 13 readings I will get. Now from the 13 readings, I can calculate sample average. I can calculate sample standard deviation. Yes or no? And whenever sample average, sample standard deviation are available, p-value can be calculated, right? And if p-value is calculated, then I get to understand the amount of risk involved in my decision. Now tell me, as a dietitian, how much risk you are okay to take while recommending this kind of product? Now put yourself as a dietitian and tell me how much risk you are okay to take. You can't say, oh, no, I don't want to take any risk. If you don't want to take any risk, then don't recommend anything.
1%.
Okay. Now alpha risk is 1%. Very good. That means 0.01. Now you should look for a p-value of 0.01 or less. Then only you can believe your study and then you can proceed. Once declared, you should not change. Isn't it? Before starting of the game, the rule must be drafted clearly. Now, this is the rule. Now, let me copy the data. Let me reshare my screen, complete screen. I hope I have already shared with all of you one Excel template. I shared one file. The name of the file is Sigma Level Calculator V7. So I am just only referring to that file. Are you able to see my screen? I am opening the Excel now. Are you seeing? Come on, please confirm. Are you
Yes,
seeing
sir.
or not?
Yes.
Yeah,
Yes.
yes, sir.
Yes.
Yes, sir.
Yeah. So now cooking oil problem, some sample data available here. Let me copy this data. You can also do it parallelly by going through the recordings. So now I copy this data and take it to Minitab. I see while placing in Minitab, I should place my cursor on the gray bar, gray row, and then this is the fat content reading. Now, what is the test I can perform now for this scenario? I am a dietitian and I have got 13 samples. My Y variable is continuous. What is the test you are recommending to me now for this scenario?
Test average.
What is test of average? Correct. But what is within test of average? There are 4 available. Now, which one
One
is best
sample.
suits now?
One
One
sample.
sample.
You are not using the word T, one sample T test.
T-test.
Because if you want to go for a G test, population parameter should be known. That is not available. So I will proceed with one sample T test. So very, very simple now. You see here, go to stat, go to basic stat, come to one sample T. Can one of you read out the description? Can you read out the description? Yeah.
Determine whether the mean of a sample differs significantly from a specified value.
Specified value is 15%.
Yes.
If it is slightly differing, I have no problem. But how much is slight I can tolerate, that was already dictated by Gurupreet. Gurupreet told me, sir, 1% risk I'm okay. That means only a smaller deviation he is ready to tolerate, not much. That is what he means, isn't it?
Yes.
Okay. So I click this one sample T. Now one or more sample in a column and summary of the data. What way we have the data? We have the data in a column. And then click here. Now which column contains that data? Column 5. Click and select. And then perform the hypothesis test. What is the hypothesized mean, specified mean? Company has advertised as 15% fat content. That is the specified mean. Now go to option. Confidence level. What is the requirement of Gurupreet? 1%.
1%.
That means he wants a confidence of 99%. That means level of significance is fixed as 1%. What is my doubt? Whether the sample mean is on the higher side. Because lower side, I have no problem. So my alternate is sample fat content more than 15 is problematic. That is alternate. It's a right-tailed test. When I choose more than symbol, it is right-tailed. When I choose less than, it is left-tailed. When I choose not equal to, it is two-tailed. Now, right-tailed test is the best option. Choose this, give OK, and one more OK. All job is done. Minitab has performed everything, and now it has given you a p-value. I want you to only look at p-value because the other statistics you have to develop some understanding before referring to it. So now p-value is, tell me, p-value, is it less than 1% or not?
Less than.
Yes.
So what are we supposed to do? We have to reject the null.
Reject.
But we made a mistake. We have not framed the null hypothesis here, right? What is your
Yes.
null? We have written, I think we have written. We have written null
Yes.
hypothesis is fat content less than or equal to 15%. Now, what is the
15%.
conclusion? What is the
Fat content
conclusion?
is higher. Fat content is higher.
But we say that reject the null.
Yeah.
Reject the null means, it actually means fat
Fat
content is
less.
not
Less.
less
Less.
than or equal to
Equal to
15%.
15%.
I won't say more than 15%. But I will say it is not less
Less
than,
than.
because for me, this is done. My purpose is not to go against the company, isn't it? Now, what is the final conclusion you make? Will you still recommend the product or you don't want to recommend?
Don't recommend.
No, don't recommend.
That's all. Your decision is perfect now. All of you understand how the hypothesis testing is working. We understood, we connected all the dots now. P-value and everything, statistics and all that we calculated. And then we understood what is statistical decision is always rejecting the null or failing to reject the null. The other option is failing to reject the null. Right? Suppose if your p-value is not less than 0.1, suppose if the p-value is more than 0.1, what you would have done? If p-value is more than 1%, what you would have done? What is your decision?
Fail to reject null.
Fail to reject.
Fail to reject. Fail to reject the null means you can't say that the fat content is not less than 15%. You can't say that. One or two readings might be more than 15, but still you can't say that it is not less than. But still, final conclusion is in your hand, yes or no? You are the king. Now you can still recommend the product or don't recommend the product. That is with you only. That is your, you apply your common sense also and then proceed. But data right now is, providing some information. When p-value is below 1%, the information coming from the data is factual. Right? When p-value, because 1% risk, you already agreed. All of you are with me on this? So p-value less than 1%, we rejected the null and decided not to recommend. If p-value comes more than 1%, you can't actually, what to say, if p-value is more than 1%, you fail to reject the null. Fail to reject the null means you are not able to prove that company's claim is wrong. You are not able to prove. But still your intuition says, don't believe the company. Then you perform some more study. You don't have to proceed with the conclusion. You perform some more study. Now don't buy 13 samples, buy 100 samples. Right? So you need to know how to use these recommendations. Reject the null and fail to reject the null. Finally, in both cases, your common sense is very, very important. Yes or no?
Yes.
But prior to applying the common sense, whether to believe the data or not, believe the data only when p-value is less than alpha. If p-value is more than alpha, we are not going to believe even data. But finally, your own judgment is also very, very important. That should also take place. Just because you use the statistics, you should not make conclusions blindly. Statistics, even after respecting all the guidelines, can still mislead you. You should know it. Say, for example, I perform a study based on the color of the dress our participants are wearing. Guru Preet is wearing blue color and Shanmugam also wearing blue color and I don't know others, right? So based on the color, I am recording your performance. And I perform a test whether color is significant to the performance. I am performing a test whether color of the dress is significant to performance. And the conclusion leads like this. If participants are wearing blue color, their performances are found to be significantly better. Will I announce this conclusion? Should I demand everybody to come in blue color for the next class? This is a kind of,
This is-
a study of nonsense, isn't it? So finally, your common sense has to be mixed up. Statistics is a guideline, but how you use it, it is in your hand, right? Data can show difference, data can generate p-value, but in what way you are using the data, in what way you are using the tools, that is very, very important, right? You can use the tools, knife for a good purpose also and for killing also. It's in your hand, right? So the same manner. Clear all of you, one sample t-test is done, one of the test of average is done. Will you be able to handle this test in different scenario? So many, now you might be able to connect it to different scenarios in your profession, yes or no? Tell me a scenario where you think the same test can be applicable. You might have come across recently. Have you validated any supplier with respect to certain standard? That means you performed one sample t-test, but you did not use statistics. You only used some mathematics and your common sense.
Yes.
People always have the ability to use mathematics and common sense. But now, if you use p-value, you are not going by mathematics. You are going by statistics. Statistics plus wise usage of common sense leads to good decisions. That is the idea. You are checking whether your son or daughter will score 90 plus marks in the exam or not. Already your son or daughter have appeared for 10 exams. Now a big exam is coming. Based on the 10 exam, you are judging whether he or she can score 90% and above, 90 or above. Now, what is the test you are performing? It's a prediction, right? Every prediction is a test. That is also one sample t-test. Clear? You have a sales record of your team. Last 1 month sales record, daily sales record is available. 30 days sales data is available. Whether your team will meet the target set by the company or not. What is the test you are performing?
One sample t-test.
During the 30 days, some days your team might have met the target. Some days they may not, they might have lost the target. But still, will they meet the target next month or not? That is my question. So with this data, you can judge. If your p-value goes below 5%, in the next 100 month, at least 95 month, your team will meet the target. But 5 month, it may miss. Do you understand? Because there are something, can go beyond our reach, beyond our control. So that is what is getting estimated with the help of p-value. So all of you are very clear now how to apply one sample t-test. Always, participants are complaining us. Sir, you are only giving very, very general example like chocolate and, dietitian and things like that. We want some practical case studies. Who is the best person to talk about the practical case studies in your field? Who is the best person?
Ourselves. We ourselves.
So I can keep silent for 2 minutes. You can now give hundreds of examples from your field, isn't it? Clear? If possible, maybe you can share. All of you can type something in the chat box. Then everybody can get educated. What kind of? Shall we do that exercise? 1 minute. If you can pull out one example of one sample t-test in your profession, please post it. in pharma industry, healthcare industry. Pharma industry, every paracetamol syrup, 5 ml if given to a child, it should give 100 milligram of paracetamol. That is declared in the bottle. Is it actually happening or not? How do you know? Often you have to perform one sample t-test. Yes or no? Often you have to check. Suddenly take 10 sample and subject the 5 ml of the syrup and to the laboratory and try to understand how much paracetamol is dissolved. What is the test result comes? If the test result is abnormally different from 100 milligram, you have to stop the production. Correct or not? So likewise, hundreds of examples can be pointed out. You want to help each other by sharing the examples? Let me see. No example shared. Tend to collaborate, tend to help each other. Hope all of you are connected via LinkedIn and share what you call some opportunities, some maybe learning opportunities, maybe job opportunities. Then you can be highly successful. Okay, everyday production target. Can it meet the month target? Very good. Okay. So all of you can type so that people can learn more from different industry example. Now I want to take you to next case. Next case is very simple. I want to now consider this as a brand A. Brand A cooking oil. And now I have one other brand. Now this is brand B. Now I want to understand whether both of them have same characteristics or different characteristics. Do you understand? Whether both of them have same characteristics or different characteristics. Now I have to actually change some values. Maybe let me change some values. 18.2, 18.4. Something I am changing. Not everywhere. I have made some changes. Now I want to understand whether both the brands have the same amount of fat content or not. This is my requirement. And now what is your null here? Come on, please. Fat content of brand A is equal to fat content of brand B. Are you able to notice the equality symbol?
Yes.
So this is actually a case of two sample t-test. Am I right?
Yes.
And even prior to drafting the null, you must have an alpha. Now tell me how much risk is tolerable for you? Normally 5%.
5%. 5%.
Here, this is not so sensitive. We are only comparing two brands, A and B. So let us proceed with 5%, p-value of 0.05. And now the alternate will be, what will be alternate? Fat content of A and B are?
It's not equal. It's not equal.
Not
It's not
equal.
equal.
Not equal
fat
means
content B.
two-tailed. It's a two-tailed test. It's a two-tailed test. So this leads to a two-sample t-test. Okay, let me go to stat, basic stat, two-sample t. Can one of you read out the description?
Determine whether the mean differs significantly between two groups.
Determine whether the mean differs significantly. Significantly means the error is limited to defined percentage. That is, then only you should use significantly. So click that. And now this window is coming. Now both sample in one column. No, both sample in one column. Now sample 1 is C5. Sample 2 is C6. Now you go to option. Can you see confidence level 95%? Confidence level 95% means level of significance is 5%.
5%.
Please note, level of significance plus confidence level will be equaling to 100%. Right? So hypothesize the difference. The difference in the fat content is believed to be 0. That is your null. Alternate. Can you see? Can you see we are choosing inequality symbol? Not equal to two-tiled. See here, there is one box here. Always while comparing groups, two or more groups, variances must be equal. The assumption is variances are equal. We simply assume and then proceed. So you tick that, give OK, and one more OK. Now the test is done. You can see here, now the test is done. 2 sample t-test for fat content. All that I want you to do is look at the p-value. And tell me what is the p-value?
0.124.
0.124. Is it less than 5% or more than 5%? More than 0.05, yes or no?
Yes, it's more.
12.4%. Since there is a risk of 12.4% associated in our data, better don't conclude anything using the data. Don't conclude. And so we fail to reject null. We fail to reject null means we are not making any decision according to the current experiment. You understand? Even though we performed experiment, we put efforts, we decided not to make any conclusion. Not making any conclusion is known as fail to reject null. You understand? Both brands are now considered to be equal only. Do you understand? Even though there is some difference, but still the difference is not significant enough to say that the brands have different fat content. Do you understand? Mathematically, it looks there is a difference. You go to the data, you will see the difference. You see here, what is the mean fat content for brand A?
16.60.
And for brand B, it is
18.
18.22.
Now, statistically, there is no difference. But still, your common sense, what is it telling? Your common sense is telling A is having a lower content. Yes or no?
Yes.
Your common sense can be used only for your decision. You understand? If your common sense is supporting, you can still proceed as far as the application is private. If the application is public, if the application is for others, you must wait till p-value goes below the defined value. Do you understand? All of you, do you understand? Very, very important here.
Yes.
This is a perfect example. We are not able to reject the null, but still, according to the statistical test, we are not able to differentiate brand A and brand B. But data, still a difference exists. Can I make a conclusion here or should I ignore the study? Come on, tell me. Should I make a conclusion or ignore the study? Should I make a conclusion or should I ignore the findings? Should I reject the null or fail to reject the null?
Fail to reject.
Fail to reject. Fail to reject means ignore the findings. Statistically, you must ignore the findings. Do you understand? Statistically, you must ignore the findings. Don't make any conclusion. That is the advice coming from data. But still, even though the statistics is warning you not to make any decision, but still you want to take a decision, that is up to you. That is why we always say we talk only about null, not about alternate. Do you understand?
Yes.
Very good. Very good. So now there are two things. And now let me pick up another example. And then probably we can go for the lunch. Now I'm going to a Excel sheet. Imagine there are 4 laboratories in a hospital and you are the chief of the hospital. You are the chief of the hospital. You want to understand whether all 4 laboratories maintain a same turnaround time for performing a particular test. What is the expectation? You want all the laboratories to perform the same, to consume, to take the same turnaround time, or you want them to have different turnaround time? What is your requirement?
Same turn.
Same turnaround time.
Because it's the same laboratory inside the same hospital, it is the same test, same equipments, same kind of people. So turnaround time should be same. But you also wanted to check. Even though same laboratory, same facilities available, still you wanted to check because you wanted to offer some kind of incentive to the best performing laboratory. So you want to go with the data. Now, what is the test, suitable test you can perform now? Turnaround time, tell me, turnaround time is continuous or discrete?
Continuous.
Continuous.
Yes.
And now how many levels exist? The factor is laboratory.
4.
The factor is lab. The levels are 4 here. So what is the recommended test?
ANOVA.
ANOVA.
Very good. Now let us perform ANOVA. And prior to that, you need to declare. Tell me what is the alpha suitable for you, level of significance for this kind of application?
5%.
Okay, 5%.
5%.
So alpha is declared 5%. And now null hypothesis. What is null hypothesis?
Same
Turnaround time
turnaround time.
are equal.
R's are equal.
Very good. Alternate.
Not
Tat
equal.
or tat are unequal. That is also good.
Not
Tat are unequal means one of them is different. And now let's perform ANOVA. So for that, we need to go to stat, go to ANOVA, go to one-way ANOVA. Can one of you read out the description here?
Determine whether the means of 2 or more group differ.
Very good. Determine whether the mean of 2 or more group differ. So click that. And now response data in one column. Do you have all the data in one single column or do you have them in separate column?
Separate column.
Separate column. And then click here. Now, which are those columns? C8, C9,
8,
C10,
9,
C11.
10, 11.
So click and select. After clicking and selecting, you go to option. Always while performing the test of averages, this condition must be enabled. What is this condition? Equal variance.
Assume equal.
I'll talk about it in detail about it, but right now you tick it. And confidence level 95%. You know why am I typing 95%? Because we all initially agreed
Because 5%,
5%.
yeah.
5% error permissible, depending on the application. And now what is the test we are performing? Right upper bound, lower bound, or two-sided? Which one we are performing?
Two-sided.
Two-sided, because we said unequal only. We don't mention more than or less than.
Less than.
So unequal. And now you click OK and click one more OK. Now Minitab has done the job for us. It has also created a beautiful interval plot. Do you know what is interval plot? 95% confidence interval. When you have average and standard deviation, because when you have sample, you can have sample average. When you have sample data, you can have standard deviation. With the help of the standard deviation and average, the confidence limits can be located. Are you able to see I section here? The horizontal
Yes.
line on the top refers to upper confidence limit. This is different from your control limit. Don't get confused. This is 95% upper confidence limit. This is 95% lower confidence limit. It simply means 95% of the time you will see the turnaround time within this limit only. Do you understand? Laboratory turnaround time for lab A, so many readings you have seen. If you one by one you check, 95% of the data will appear in this range only. But 1 or 2 or 5% of the data might appear beyond this. All of you, do you understand?
Yes.
Same manner, Minitab has calculated the confidence interval for laboratory 2 also, laboratory 3 also, laboratory 4 also. Now, by looking at the diagram, without even looking at the p-value, just by looking at the diagram, will you be able to find out, is there any laboratory significantly, taking significantly higher turnaround time?
Yes, sir.
Yes, sir.
What
Laboratory
is that
3.
lab?
Lab 3.
Now
Lab
you are
3.
not using p-value, but straight away you are able to make a conclusion. How much confident you are right now in saying that laboratory 3 takes more time? How much confident you are now?
95%.
100%.
95%.
Because 95% of the data is confirming that lab 3 consumes more time than other laboratory. Yes or no?
Yes.
The
Yes,
remaining
sir.
5% of the time, the point can fall anywhere. I don't know that. That I need to read from the data. I don't have that much time because there is 10,000 data, 1 million data. Can I check each and everything?
No.
So I decide based on this only. I am 95% confidently saying that, or I make a statement with a risk rate of only 5%. I'm saying that laboratory 3 is consuming a higher turnaround time in comparison to all other laboratory. And so I am applying a penalty to the laboratory 3. No increment or no incentive. All of it, you understand? Is it making sense, this decision?
Yes.
Yes, sir.
Similarly, one more statement I can make. I can make a statement about lab 4. Similar situation exists for lab 4 also. What is the statement you can make now? Laboratory 4
4.
is
Taking less
consuming
time.
a significantly lower turnaround
Yes.
time than any other laboratory. Only in statistics we use, the word significant. Mathematically, we only say laboratory 4 takes lower time. But when I say significantly lower, at least 95% of the time my statement is true. That is the meaning of adding the word significantly. Clear, all of you? So now 95% of the time I have seen the laboratory 4 consuming a lesser turnaround time. So I decide to provide an additional incentive to laboratory 4. Is my decision correct as the chief of the hospital?
Correct.
Yes.
Yes.
Correct.
Yes, very good. But will I be able to differentiate between 1 and 2?
No.
No.
We
They are
need
There
to
is
make
no
more
significant
study.
difference. There is no
You
significant
are
difference.
confused. You are confused. That means the risk of your decision going wrong is very higher. Looking at the graph. Just imagine I am moving the left eye section from left to right. Will it overlap with the laboratory 2? It will cross,
Yes.
If I move the eye section of lab 1, it will certainly cross lab 2. That means the risk rate is more than 5%. If I move laboratory 3, it is not overlapping with anyone. Can you see here?
Yes, sir.
I can move left to right. The error is definitely less than 5%. These are all some physical, visual way of understanding the significance. I have not used even p-value. Whenever the difference is more, you don't require p-value. Yes or no?
Yes,
Clear?
sir.
All of you are with me? Now let us read the ANOVA report and try to understand. Now come to ANOVA. See here, the factor is laboratory. The levels are 4. What are the 4 levels? Lab 1, lab 2, lab 3, lab 4. Now, as far as the factor, what is the p-value?
Almost 0.
Below 5%. That means the factor is significant. You must definitely use the findings of the data. You must definitely use the findings from the data. What is the findings from the data? Lab 3 consumes more time. Lab 4 consumes less time. There is no difference between 1 and 2. All these statements are correct. Clear, all of you? Clear?
Yes, sir.
Very good. So, if for the same data, if I want to study only laboratory 1 and 2, what do you think? If I want to compare only lab 1 and 2, now what test you recommend me, all of you? Tell me now.
Two sample T test, sir. Two
Two
sample T
sample
test.
test.
To sample t-test.
Very good. You are now able to guide me, right? guide me, select the right test, two sample t-test. But for but in wherever two sample t-test can be done, I can also perform ANOVA there.
Correct. Correct.
These are two different methods taking you to the same destination. From your office to home, you can go by car also, you can go by bike also. You are reaching to the same place only. But maybe going by car is little more safer, little more comfortable. Same is the situation. ANOVA, ANOVA is, the error rate or the accuracy with ANOVA is higher. Otherwise, you can do both, right? So now, tell me, I want to understand whether the laboratory A is able to perform the diagnosis with the turnaround time of lesser than or equal to 190 minutes or whatever. What is the requirement now? I want to check whether lab A is capable of performing the diagnosis in less than or equal to 190 minutes. Do you understand my question, my requirement? Now, what is the test I
Yes.
should do? What is the test I should
ANOVA.
do?
So that would be
ANOVA.
one sample t-test, no, sir? That will be one sample
Understand the
t-test, sir.
situation. I have only one laboratory now.
Then
And I have a
one sample
One,
requirement.
that
t-test.
is one sample t-test, sir.
One
One
thing,
sample
One sample
Very
t-test.
good. Very
One
good.
sample t-test.
Very good. Fantastic. One sample t-test. So go to stat, go to basic stat, go to one sample t-test. And now your sample in a column. Yes. And which is that column? I want to do it for A. And what is the reference value? 190.
190.
190.
And go to option, confidence level 95%.
95%.
And alternate is more than 190. Because you are checking, less than or equal to. So more than will be the alternate. Give OK, give one more OK. And now look at your p-value. What is your p-value?
One.
P-value is below, sorry, not below, more than 5%. That means what is the condition?
Fail to reject null.
Fail to reject null means you can't declare that laboratory A takes more turnaround time. But actually, if you look at the data, there can be some points where they are taking more time. Can you see here 193?
Yes, yes.
Yes, sir.
There are few occasions where they take 193, but still you cannot declare it. Do you understand? Because 95% of the time they are okay. Do you understand?
Yes.
Yes,
Yes.
sir.
Right?
And the
So,
number of occurrences is not significant. Correct, na, sir?
yeah, exactly. So, since fail to reject the null, you proceed with the null. What is your null? That is less than or equal to 190.
Above.
So this is how you need to use. You can do it for a laboratory. If I do it laboratory wise against a reference, then it is one sample t-test. If I take two laboratories at a time, it is two sample t-test. If I take two at a time or any number at a time, then the test is ANOVA. Then the test is ANOVA. Now, one another example. Sorry to delay all of you, your lunch, but one other example. Now, for the same fat content, because I have not explained the G test earlier, so let me finish that also. Now, imagine for the fat content problem, now the company is ready to cooperate by providing you the population data. Do you understand? Company is ready to cooperate. Why the company is ready to cooperate? Because the test is completely internal for some useful reason. All of you understand? Now the company gives population average. Company also gives population standard deviation. This is very important to me. Population standard deviation, you have to use the symbol sigma. For population standard deviation, you can use the symbol sigma. Then for the sample, the symbol for standard deviation is capital S. All of you understand? Hereafter, wherever you write sigma, it refers to population standard deviation. Whenever you write capital S, it refers to sample standard deviation. All right. And now, I want to check whether the fat content of a particular brand is having the, what do you call? The fat content is less than or equal to 15%. That is my null. And so the alternate is fat content more than 15%. What is the test I need to do now? Tell me.
Sample Z test.
That is very. Why I am preferring G now? Because population
Population
standard
is low.
deviation is revealed. Right. So I go to stat, I go to basic stat, go to one sample G test. Stat, basic stat, one sample G test. Now come here, one or more sample in a column. Yes, we have it in a column, and that column is fat content A. And known standard deviation. What is the standard deviation? Population standard deviation.
Population standard.
Whatever value company tells, you have to type it. Now you perform hypothesis test. And what is the reference value? 15. Now go to option. Your 95% confidence level, your alternate is more than. See, if you don't give population standard deviation, Minitab will make use of sample standard deviation. If company doesn't give standard deviation, we can still calculate standard deviation from the sample, yes or no? But sample standard deviation will differ from the population standard deviation. If I use population standard deviation, I get more realistic understanding. Yes or no? So the advantage with
Yes,
G test is it is more accurate than T test. My limitation on the sample size, I can overcome. Do you understand? So whenever you are performing G test, even with a lower sample, you can still make a better conclusion. But a T test, it is always a good idea to keep your sample size on the higher side. Do you understand? Yes or no? Because
Yes.
you are replacing the population standard deviation by sample standard deviation. So the chances of your sample standard deviation differing from population standard deviation is higher. To control that, the only way you can control is go for a higher number of sample. Clear? But now the situation is favoring you. Your company has given. Now give okay, one more okay. Now look at the p-value. What is the p-value now?
0.013.
Once again, it is less than 0.05. Less than 0.05 means reject the null. That means again we are making the same decision. Don't recommend the product. Again, you are making the decision, recommend the product. 0.13 means what is the percentage of risk, alpha risk? What is the alpha, how much is the alpha risk estimated? What is the estimated risk? 13%, yes or no?
Yes.
If you want to decide something with 85% or 87% confidence level, you can proceed. Do you understand? So ultimately, how much risk is permissible in your current situation? Accordingly, we use the data. If somebody is very lenient, giving you very liberal tolerance, go for a risk rate of 20%, then now you can recommend your cooking oil thing. See, imagine some people are selling fake medicines. Have you seen? They are giving
Yes,
some
yes.
oil. If you use that oil, no, then you will see hair growth everywhere in your head. Now, how much is the risk rate they are running? They might be running. Hardly 5% of the people see some result. Yes or no?
Yes,
So how much is the risk they are taking?
95%.
So that is their nature of business. But if you want to sell such oil, you must ensure the risk rate is below 5%. Your company will grow fast. Yes or no?
Yes.
Yes.
Hair will also grow, your company will also grow. So that's all from me about test of averages. There are 4 tests, all 4 we have seen. I have limited my discussion to only few examples, but I strongly believe all of you are intelligent enough to use it in your field, isn't it? Whenever required. All that you need to look at is your Y variable must be continuous. X variable must have different levels. One level means one sample t-test, two level means two sample t-test, two or more means ANOVA. There are much more tests which I will be educating you as we progress, right? Helpful?
Yes, sir.
Sir.
Okay, then you can proceed for the lunch. So thank you very much for your good participation today. I've seen very lively engagement of the participants. Please continue doing it always, no? So you need to also ensure your trainer is doing a good job for you, which is possible only when you interact, which is possible only when you show your face very often. If you are always off, then we will simply think that you are not here in the program. So that will slow down everything. Okay, so we will go for the lunch, 1 hour lunch break, and 2:15 you are expected back.
By 2:15. Okay, sir.
Yeah, 2:15. 55 minutes only lunch. 5 minutes
Okay, thank you.
reduced.
Thank you, sir.
Okay.